everybody, and welcome to the Virtual Character Behavior Planner video. My name is Chloe Josian.
My name is Logan Peterson.
My name is Jonathan Chan.
And my name is Alex Chen.
And this is our project. So, what is the Virtual Character Behavior Planner? Well, let's think about a Rubik's Cube. They're kind of tricky to solve, right? So, what if you want to be able to solve that Rubik's Cube and visualize it being solved? Well, the Virtual Character Behavior Planner can help you with that. In fact, it can solve and simulate almost any type of search problem. So, in the real world, our system is integrated into Unity, and our users are just about anybody who has an understanding of Unity and PDDL who would like to visualize their search problems. So the purpose of this project overall is for users to be able to import their PDDL files into Unity, and then we translate that code into something that they can visualize. And this didn't exist before. And we have a sponsor to our project, Dr. Cardano Rivera, and he is really excited about what the team has accomplished during the semester. And he does plan to make this project available as a resource to the community that wants to simulate high-level task planning in close to real-life virtual environments. So let's define some things for a second here. What is a search problem? Well, a search problem consists of an initial state and a goal state, and at each state, you have actions to transition to another state. So like turn right, turn left. And a solution to this search problem is the minimum number of actions it takes to get from your initial state to your goal state. So if you think of a search problem like a graph, your initial state is a starting node and your goal state is the goal, while all the actions are different edges to different states. So let's look at this visually. So here we have a Rubik's Cube example again. If you have a Rubik's Cube like up at the top, you can rotate the right side vertically and you get a solved cube. But you could also rotate it to the left or to the right, or any number of combinations. What is PDDL? Well, PDDL has two files. They are a domain and a problem file, and those represent a search problem. So your domain defines the search space. So with our cube, it defines the ways you can rotate it. The problem defines the search problem. It has the initial state of a mixed cube and a goal state of a solved cube. This format is really nice for planning because a domain can be used with multiple different problem files. So at the bottom here, we have two Rubik's Cubes. They're scrambled differently, but it's still a Rubik's Cube. You can still turn it the exact same way. You just have two different scrambles. And it's really nice to be able to visualize and see both of those. Okay, so now let's look at the demo. So everything you see here, unless it is labeled VCBP or Virtual Character Behavior Planner, is Unity. But now let's look at the special things that we've added to Unity to make this work. So you first have the option to import a PDDL file. So here we have all of our PDDL files. These are already imported for our demo here. So I'm just going to close out of this. And if I click on this PDDL files folder, you'll see all the files are already here. From there, I will now select Generate a Manager, and you have to click on a domain. We're going to open that up. And a new domain sample manager appears. So in this manager here, you now have the options to change settings. So if I select settings, you can pick breadth first or fast forward. Let's go with fast forward for this example. You can also select a problem file. So I'm going to select the first problem file, problem sample, and then we're going to name our problem file. So I'm just going to leave it as plan. Actually, let's name it plan solution. And we're going to generate that plan. So currently it looks like nothing has happened yet, but that's because we had to set up the scene. So we are going to assign prefabs to our packages. So and once we've selected the prefabs, we can click on Advanced Settings. And if we want to place an object in a specific place, we just have to type in the XYZ coordinate. I'm just going to leave it as is and click Generate Scene. Now that we have the scene generated, you can see we have our little robot. We have all of the different locations. And we have our boxes here. So I am going to pull up now a demo scene that we have already built. And ta-da. So as you can see, you have your same objects here. We just have them in different colors. And I'm going to go back to this manager. So in the manager itself, we can open up this plan runner script. So you can select whether you would like to run with initial predicates and set up your action scripts. So you have those scripts in your assets folder. And then you also have your plan here. So this is already implemented with our pre-written scripts. And so now I am just going to run and we're going to watch the robot move. And if I click here, you can see as the plan goes, we see what step it's on. And so our robot picks up the package, grabs the package, and then is going to go drop it off. And it's dropped off the package. It's dropped off the other package, and now it is going to return to its location. And that is our demo. So, what did it take to build this project that you just saw? So as you saw, our project is built on top of Unity, which is a C# based language. So all of the backend code has been built in C# using Unity libraries as well, so we could integrate things fully. We also built our own custom planner using both breadth first search and the fast forward search algorithm to be able to solve the PDDL files that we have. Over the course of the semester, we also closed 101 tickets on our GitLab boards. And we showed our project to 3 different users who all enjoyed the fact that we had fully integrated our project in Unity. And they also helped us create a better UI that is more user-friendly and also a more clear step-by-step user guide. So here is also our architecture diagram for our project. So all of this is built into Unity, and as you can see, similar to the demo, the user has to give us a domain file and a problem file, which then gets sent to our PDDL parser, which then gets sent to a loader in the planner, and then that loader sends objects to the simulation generator and our PDDL planner. And the PDDL planner spits out a solution file, and it also sends that solution to the simulation generator. Our simulation generator also gets some user inputted prefabs, and they have to implement the action scripts along with the predicate scripts if they so please. That simulation generator then spits out game objects and a new simulation manager that the user can manipulate, and now you have a visualized system. And that is the end of our project. So thank you so much for your time, and I hope you enjoyed seeing our demo.